Chapter 4, Number 27. A certain projectile is launched with an initial speed v0. At its highest point, its speed is 1/2 v0. What is the launch angle of the projectile? So, quick kind of sketch here, as usual. We have the ground. We fire our projectile with some initial angle and some initial velocity. And then the projectile follows what's supposed to be a parabola, close enough. And at the highest point, it has a velocity which is, in magnitude, 1/2 the initial velocity. The key thing to remember is that at the highest point, the object is traveling entirely horizontally. Let's be a little bit more scaly. So here we have 1/2 v0. I know it's going entirely horizontally because it's at its highest point, which means it is neither going up nor has it started to come down. It must not have any vertical velocity. It's sort of useful to keep in mind that that's the same thing. That saying it has no vertical velocity is the same as saying it's at its highest point. So in this case, what we end up with is that the velocity at that midpoint, which we're going to call its final velocity, in the x is 1/2 v0, and in the y, it's 0. Now, looking back at our original velocity, it has speed v0 and angle theta, and we know that that can be expressed as a component which was v0x this way and v0y that way, and they are by definition at a right angle. So if we could find two of these sides, we could get the angle. And then we look and we say, well, it's a projectile, so that means that there is no horizontal acceleration, which means that the horizontal velocity never changes, which means that the final velocity in the x has to always be the initial velocity in the x. And that doesn't matter where I am. It doesn't have to be the same height, doesn't have to be anywhere on the parabola. The horizontal velocity will be the same, which means that the initial horizontal velocity must have been 1/2 v0. So I actually have a triangle that looks something like this. Here's v0, here's theta, but now I know that this is 1/2 v0, and this is the unknown v0y. Looking at our triangle, we have this. That's going to be our adjacent side, and we have this, and that is our hypotenuse. And we know that the cosine of the angle is defined as the adjacent over the hypotenuse. So it's going to be 1/2 v0 over v0, which of course is just 1/2. So I just need to find an angle whose cosine is 1/2. And that of course says that the angle theta that our angle theta is going to be the inverse cosine of 1/2, which I just get from my calculator to be 60 degrees. So it must have been launched at 60 degrees, which is that one. In principle, we could have sort of gone the other way and just said, try the cosine of 30, cosine of 45, cosine of 60, and cosine of 75, and see which one gave us 1/2, and that would be fine as well.